All right, I'm sure you're tired of all this, but there is a bit more to go through, and that is the process of automating your data cleaning. So data cleaning can be very repetitive, but you should not let it be. You can save yourself a lot of time by letting the computer do the work. We've already done a little bit of this with something like in. The in function says, hey, is this value any one of these, right? And it checks every single one of the values. Instead of having to write is a equal to 1, or is a equal to 2, or is a equal to 3, or is a equal to 4, instead you just say is a in the vector 1, 2, 3, 4, right? So this saves yourself a little bit of work. You can save yourself work in very similar ways in other places. So also, not only will it save you work to automate your process, it will also reduce error and also make changes easier. If you have a single function that you apply many different times, then if there's an error in that function, you only need to change one thing to fix it all. Or it will prevent you from making a typo in just one of the many iterations that you make. So we're going to automate. I'm going to show you 3 different ways to automate. I'm going to use the across function. I'm going to talk about writing functions in R, and I'll talk about the per package. So across, if you have a lot of variables in dplyr, then cleaning them all at once can be a pain, especially if you're doing the same thing to many different variables. You can convert, for example, let's say you have a bunch of different variables that are all numbers stored as character variables, and you want to convert them all to numbers. Well, you can use the across function to do this. If you look at online, you might find old code that uses things like mutate at or mutate if. These are all old functions that are deprecated. As of dplyr 1.0, you want to use the across function instead. Across lets you use all sorts of variable selection tricks that like talk about select, like starts with, or names across a range, or index positions, all this sort of stuff. And then you can apply the same function to all of them using mutate or summarize. There's also functions called rowwise and cacross that let you do stuff like add up a bunch of columns like we did before when we added Midwest and Northwest and East and South. All those you could have used rowwise or cacross to do that instead. I'm not going to go into those, but those are out there. So the example here is some data with some stock tickers and some prices on different days. Let's say I want to do something like first of all, I can calculate some stock price growth by grouping by the ticker and then doing the stock price relative to its first value in the data set, or take it relative to the day on the previous day. So I've got price growth on different days and also the price growth since a certain date. Right? So if I look at this data by itself, I look at stock growth, you can see that I get percentage changes relative to March 4th and also relative to the previous date, which is missing for the first day because there is no previous day in the data. Now, this is percentage growth, so this is 0.3% change. But let's say I want to change that into basis points. I can change all of them into basis points at once with across. So I'm going to take this data right here, which is price growth. I'm going to change both my price growth variables to basis points by multiplying them by 10,000. So I'm going to use across inside of my mutate. The across function goes inside the mutate function. I'm going to apply this to all of the variables that start with the words price growth. So that's my price growth since March 4th and price growth daily are both going to get changed. And I'm going to apply a function to them to manipulate them. Specifically, I'm going to do a function that multiplies it by 10,000. And then that's it. This converts all of them to basis points. So instead of 0.0038, I get 38.8. Right? Easy enough. So this works whenever I want to apply the same function to many different variables. So let's say that I want to take, let's say I'm working on my GSS construction data, right? Let's say for some reason I want all of these to be string variables. Right? I want everything to be string variables. So I'm going to do mutate across. By default, it will do all of the things. So I'm going to do everything. And I'm going to apply the same function. I'm going to do as character. And now suddenly all of my variables are character variables for whatever reason I wanted to do that. Let's say maybe instead I want to do, let's say, Northeast, Midwest, and South to be just character variables. So I'll do vars, Northeast, Midwest, and South. Oops, didn't like that. Always forget how to use vars. Didn't like that either. What am I doing wrong? Well, I'll cut this out. So I can very easily do the same function to all my variables. I can pick just some variable names with something like starts with or ends with or whatever to do it up to a bunch of different variables at once. I can manipulate it by multiplying it by a certain thing. Notice I sort of created my own little function here by just saying function of x x times 10,000, and it applied multiplying by 10,000 to all of these variables. Or I can apply a canned function, like turning everything to a string with as.character, or turning everything numeric with as.numeric. I can make this a lot more efficient by writing my own functions. If you're going to generally do the same thing more than once, you're probably better off writing a function to do that thing. This will reduce error, save time, make code reusable. I mean, here I'm using the same multiply by 10,000 function to multiple different variables. Function writing in R is not that difficult. I'm not going to go super deep into it. Basically, you can create a function name object. You assign it using the function, where you specify what the arguments of that function are going to be. You write the calculations you're going to do, and you return the result of the function. So for example, I could do the exact same thing that I did before by creating a do basis points function, where I take a value p, I take that value p, I multiply it by 10,000, and I return the result. All right, so here's my function right there. I can say do basis points of, let's say, 0.0006, and it gives me the basis point version of that. I can then apply that with across. So mutate across starts with price growth, so I'm going to do this to both of the price growth variables, and I'm going to do my do BPS function to it, and then this will give me back the basis point values. Next, I'm going to talk about per as a way of automating. So per is a way of applying functions iteratively. These can either be your functions or not. Across is for applying the same function to multiple different columns. Per is about, the per map function is about applying the same function to multiple different objects. So for example, let's say I have my a vector like this. I'm going to first of all load per, library per. Let's say I'm going to do the values 0.0006, 0.05, and 1. And I'm going to type that to map of my do basis points function. This will apply my basis point function to each of these different objects. So I get 0.6, 500, and 10,000, right? Which is just multiplying 10,000 by each of these. There are different kinds of map functions which determine what kind of result you get back. So here I've gotten what's called a list, which is a very generic kind of object that can hold all sorts of output. But maybe I'm saying, hey, I know these are going to be numbers, so I want this to be a map double to return a numeric vector. Right, that's what I get here. So it iterates through the list of objects that you give it. In this case, it's going through the list of numbers that I've given it, and it's applying the same function, do BPS, to each of them and giving me back a result. So here, for example, I'm using map character to get the class of each of the variables from my person year data, and it's telling me that the person variable is a character, the year variable is numeric, and the income variable is also numeric. This can be handy for a lot of different things. One thing that you can use it for is reading in many different files. There's a list.files function that creates a character vector of file names, and then you can pass that list of file names to map df with the read CSV function. It will read each of those CSVs in one at a time, and then pop them all together as a single data set. I use this quite a lot for if I have data that's broken across multiple files, I can read them all in and pop them all together with map df. Let me show you that in practice. So let me find a folder here that has a bunch of files in it. So let's look at this folder right here. Let's go ahead and set my working directory to that folder. Okay. So list files, if I just do it by itself, it will give me a list of all the files in this folder. I want all of these particular trends up to files. These are all the same kind of data, just split across multiple files. So I'm going to look for pattern equals trends. This will give me just all those trends files. Now this is a vector of file names. I can pass that to map df and read CSV. And what this will do is we'll apply the read underscore CSV function to this first file and read it in. Then it will do the second file and read that in. And then it'll do the third file and read that in. And then I will have a list of data sets that have been read in from these various files. And then because I'm asking for a data frame back, it will pop all those files on top of each other. It's going to read them one at a time, iterate through all of them. And when it's done, stick them all together. And we can see the data set that it popped out, which is a single data set with about 1.6 million observations in it. This is a lot easier than writing out data 1 is read CSV of trends up to 1.csv, and then doing that again and again and again and again and again and again, and then using bind rows of data 1, data 2, and so on, right? That's a lot of work. You don't need it. just use a loop. This is basically a looping function that then processes the results for you. So you can do that to read in a bunch of files. You can do it to apply a function to a bunch of different stuff. You could do it to, let's say, run a summary profile on a bunch of different states or whatever. You can also use it just in place of a for loop. You don't need to learn how to use R's for loops because you can just use map if you like. Create a function and then just run it through whatever you want. So here's an example. I'm going to create a function here called myFunction. All that it does is it prints out the number that is 1 bigger than the number I give it. I take it the numbers 1 through 10, I pass that to map of my function, and it will print out the numbers 1 bigger than the ones I gave it. It will print me 2 through 11. There's also, of course, a per cheat sheet for learning some of this stuff. All right, so those are some of the ways in which we can apply automation to make our lives easier. We can use across to apply the same function to multiple different columns at the same time in our dplyr commands. We can write functions to make that process a little bit easier. We can also pass those functions to per to apply the same function, whether we've written it or not, to many different objects, either reading in a bunch of different files or doing the same sort of calculation on a bunch of different objects, whatever it is that we'd like to do. We can also use different kinds of map functions to get back different kinds of structured output. Map by itself will give us a list, which often is not what we want. At least it's not the easiest thing to work with. We can also get back a vector of numbers, a vector of strings, maybe a single data set that pops all the different data sets that we like. All right, that's it.